question 11, the diagram shows a part of the curve and a point P that lies on the curve. The normal to the curve intersects the x-axis at Q. So in the first part, we have to find the x-coordinate of Q as 16 upon 9. To find the x-coordinate of Q, we need the equation of the normal. To find the equation of the normal, we already have the point. To find the gradient, we'll find the gradient of the tangent and then take the negative reciprocal. So y is equals to 3 into 1 plus 4x to the power minus 1 upon 2. Differentiating this, we get dy dx is equals to minus, so minus 1 upon 2 will multiply by 3 and become minus 3 upon 2 into 1 plus 4x. Decreasing the power by 1, we get minus 3 upon 2 into 4. So the dy dx is minus 6 upon 1 plus 4x to the power 3 upon 2. P is a point which on the normal, so it means we can use x equals to 2. Substituting x equals to 2, we get minus 6 upon 1 plus 4 times 2, 8. So 1 plus 8 is 9, 9 to the power 3 upon 2. So 9 to the power 3 upon 2 is 27, which gives us the gradient of the tangent as 2 upon 9. So this is the gradient of the tangent. The gradient of the normal would be positive 9 upon 2. Forming the equation of the normal, we'll get y minus the point P is 2, 1. So y minus 1 is equals to 9 upon 2 into x minus 2. For the coordinates of Q, we know that it is lying on the x-axis, which means the coordinates will be x, 0. Substituting 0 in place of y, we'll get minus 1 is equals to 9 upon 2 into x minus 2. So this will become minus 2 is equals to 9x minus 18. So minus 2 plus 18 will be 16. So x is equals to 16 upon 9. In part 2, we have to find the area of the shaded region. Now the area of the shaded region will basically be, if we find the total area under the curve and subtract the area of this particular triangle, we will be able to find the shaded region. So the shaded region area of the shaded region will be given by area under the curve minus the area of the triangle. So the area under the curve will be given by first integrating the equation of the curve. So the equation of the curve is 3 into 1 plus 4x to the power minus 1 upon 2. The limits are 2 and 0. Integrating this, we get 3 into 1 plus 4x to the power positive 1 upon 2. As we add 1 when we integrate, we divide by the new power, which is half, and multiplied by the derivative of the function, which is 4. So we get 3 upon 2 into 1 plus 4x to the power 1 upon 2. Substituting the limits 2 and 0, we get 3 upon 2 into 1 plus 4 times 2, 8. So this will be 9 to the power 1 upon 2 minus 3 upon 2 into 1 plus 0 to the power 1 upon 2. The area under the total area under the curve will be 9 upon 2 minus 3 upon 2, which is equals to 6 upon 2, which is 3. Now the area of the triangle would be, so we know that the height of the triangle is 1 and the base, we know that the coordinate of P is 2 and the x coordinate of Q is 16 upon 9. So the base will be 2 minus 16 upon 9. So the area of the triangle would be half into base, which is 2 minus 16 upon 9 multiplied by 1, which becomes 1 upon 2 into 18 minus 16 upon 9, which is 2 upon 9. So the area of the triangle is 1 upon 9. Subtracting the area under the curve from the area of the triangle, 3 minus 1 upon 9 will be is equals to 28. 9 6 are 27 minus 1 will become 26 upon 9.